Hey, what's up? I'm back here with another, important topic from aldehyde ketones in carboxylic acid. And in case you have idea what I'm doing this day, then that's okay. If it's not, let me tell you about. I'm doing preparation of carboxylic acid. I've done a couple of conversion that relates how carboxylic acids can be prepared. And in that sequence, this is going to be 2 or 3 conversion here, and along with that their mechanism. What these 3 method I'm talking about, which prepare this carboxylic acid, is one from the haloalkane, and the other is from Grignard reagent, and then there is going to be from alkyl benzene, right? So let's start that and see what this is all about and how important this is. So like I said, I'm starting from haloalkane to carboxylic acid. This is what our main concern is. So this is going to be a conversion, but at the same time going to be reaction mechanism as well. So let's try to get through here. When you react an alkyl halide, what this is, you probably know that, but in case you do not, let me write. This is your alkyl halide. So when this alkyl halide react with potassium cyanide, what happened here? This react with potassium cyanide, right? So when it react with potassium cyanide, you probably can easily understand that when this bond will undergo cleavage, you have to understand when this bond will undergo cleavage, chlorine being electronegative, than carbon. So what will happen? The alkyl will form a positive charge while the chlorine will form a negative charge. Similarly, this potassium cyanide will also undergo cleavage, and this will result formation of a negative charge here, and K will come out as a positive charge. So what's happening here? You are getting RCN. So you are getting RC triple bond N. So this is your nitrile actually. Remember the very last video, the very last lecture where I did the conversion from nitriles to the carboxylic acid. So this is also going to remind you how nitriles are converted into carboxylic acid. So the first thing we did was we get this nitrile. Another byproduct going to be this is going to be KCl. So this is going to be your byproduct. This is going to be KCl. Now what happened? I don't think that's important here to be mentioned. So I'm removing that KCl, and in case you need maybe I can write here minus KCl. Right? So this is your byproduct. Now what happened in the next step? You react this react this nitrile with water. You react it with water, right? And how water react? Actually, you can also write water. You can write hydronium ion or any, right? So what happened here? Let's make this only water so that you don't have problem. So what happened? Two of the bond undergo cleavage here. Two of the bond undergo cleavage, and nitrogen receive these 2 hydrogen while the carbon receive the oxygen. So this forms RC, you get your double bond right here, and then you get NH2. You get NH2. So what this is called? Amide. So this is again very important going to be. Remember another very something from the past. I did some conversion from amide to carboxylic acid. Now what happened in the last stage here? This is treated again with water. You probably understand that the system has plenty of water. So if it has water, what will happen? What will happen? This entire NH2 will be converted. This entire NH2 will be occupied by the hydroxide group. So that's what the reaction is going to. That's what the reaction is going to be. RC double bond O, and this is going to be OH, right? So that's how the reactions takes place. But if you want to understand what happened here, there is a hydrogen ion also. So you can also write it like proton is also released by the end of the reaction. So this is the reaction that relates how a haloalkane can be converted into carboxylic acid. So this is the first one. I hope I've helped you. Now let's go through the second part. What the second part is, let's take an example here, like maybe take alkyl benzene, right? This is going to be something new here. So this is a alkyl benzene here, right? Now I'm placing a methyl group here. So when this alkyl group, you have to understand that when this alkyl group undergo oxidation, you have to understand that this is a vigorous oxidation. What vigorous oxidation means? You have to, just give me a second, you have to use strong oxidizing agent KMnO4 and along with that you also need, a basic solution, maybe KOH you can use. So a strong base is also required, and along with that, what happened, you also have to provide some heat also. So I'm writing plus heat also. So when you provide the oxidizing agent here, you don't need to worry about what mechanism is going to be here. You just have to feel concerned how you can convert the alkyl benzene directly into carboxylic acid. So what happened here, this acts as an oxygen donor, and this oxidizes the, you have to understand, this oxidizes the carbon right here. Doesn't matter how many carbon there are. So this converts into, carboxylic acid. So what do you get? You get this one. You get, this one. And what this is called? This is called benzoic acid. So this is another very important, conversion you're going to have. So this is a benzoic. Okay, so like I was saying, this require, quite a vigorous oxidation condition where, the entire side chain converts into a carboxylic acid. Let's take another example from the same lead here. So what I'm doing, I'm taking another, alkyl benzene here, but this time it's going to be slightly different here. What different is here? Suppose I'm taking not just, one carbon, but also more carbon. So it's ethyl here. There it was methyl, now it's ethyl. So what happened? You have to use again the very same condition. What that same condition is, you have to use strong oxidizing agent, along with that basic condition, and along with that you also need to heat the system. So what happened, I have to remove this name right from here. So what happened, this entire, chain, irrespective of the length of the chain, let me tell you, irrespective of the length of the chain, doesn't matter if there are 2 carbon or 3 carbon or whatever, 4 carbon, 5 carbon, right? If there is hydrogen here to the carbon to which is exactly, attached to the benzene, if it has hydrogen, then that carbon will be, only this carbon is going to be, doesn't matter what's going to happen to this one. So this has nothing to do with carboxylic, but this will convert, let me write here, this will convert to carboxylic, COOH, right? You have to remember that. So what happened now? You have this acid again, which is also the benzoic acid. Now, if you have a doubt what's happening with the rest of the carbon, they oxidizes into something else. But this is not what the concern is. What concern is, we are preparing the carboxylic acid. So an alkyl benzene, doesn't matter what length of the alkyl group is, it directly converts into a benzoic acid. That very first carbon oxidizes into carboxylic acid. Let's take another equation here and then see what this is all about. So I'm writing here, and I hope I will make it up within this very short clip. So what I'm doing, I'm taking this very next alkyl benzene. Now what is alkyl benzene? You have got, suppose you have got, this is what it looks like. So you have, a different alkyl group here. Now what this is a secondary, carbon here, but it still have that carbon. If it still had that carbon, then what happened? If you reacted with the potassium permanganate, KMnO4 along with potassium hydroxide, and you put some heat through the system, what happened? This will again convert into benzoic acid. So this is what it will happen. So this will again convert into benzoic acid, right? So COOH, this is what happened, right? Now, what very important thing is that now I've started with first carbon here, then the second carbon here. Now there are 3 carbon here. So right, let's see what happened with the tertiary carbon. So if there are 3 carbon on the benzene, we need to find out what that happened. I'm taking another alkyl benzene, but this time it's going to be a tertiary, and also you have what happened here. So this is your benzene here, and there you have your carbon. Should I put it over there because it might be directed? So what happened? You have, this is the kind of, situation you have. H3C. So what it looks like, just give me a second, I have to make sure it's coming out there. Yeah. So what happened here? This is a tertiary carbon. Now what happened if you, let this alkyl benzene go through, oxidation using the KMnO4 and along with potassium hydroxide, and also you put some heat through the system, what happened? This carbon doesn't have a hydrogen. You need to understand that the carbon doesn't have a hydrogen, and because it doesn't have a hydrogen, it does not oxidizes into carboxylic acid. So what I'm going to do here, I'm going to happen, no reaction takes place here. No reaction takes place, right? If you want to know what's the reason is, the region is itself in the tertiary carbon. A tertiary carbon is highly stable, so it's very difficult to oxidize that carbon, right? And that's the reason this does not. So there are four types of alkyl benzene reaction, where three of them are able to produce the carboxylic acid, while the fourth one is not able to produce that, right? So this is how you can carry out some more conversion using alkyl benzene, or you can use that haloalkane, right? So in the first one, where I used that haloalkane, there was two more reaction actually. It was not just to convert the haloalkane to carboxylic acid. There was some, from haloalkane you were producing amide. So that is one conversion. Let me repeat. There is one conversion from haloalkane to amide. And then from amide you produce the carboxylic acid. So then there was two reaction in one conversion. So you have to be very careful taking every all of these reactions together. That will help you to take every question from the board exam or from your NEET exam or whatever type of exam you are having. But trust me, organic chemistry, it's something I'm taking you through. This is what exactly organic chemistry is. So I hope I've helped you, and see you in the next lecture.